Hello folks, so I mentioned this in the last video kind of accidentally and it didn't quite work out, so I wanted to make another example to kind of clarify this. And this is a video on how to take care of converting rectangular coordinates and writing them as polar coordinates when theta is not quite right, and I'll explain what that means. So remember that if I have x and y, the rectangular coordinates of some point, then you essentially have the legs of this triangle. And to find the polar coordinates, you need r, which is the radius or the hypotenuse of this right triangle. So that's pretty straightforward. Our hypotenuse, oops, sorry about that. Our hypotenuse is going to come about as, I think I've been using purple for polar. R is equal to, or r squared is equal to x squared plus y squared. You're a lot of times going to see this, but it's just as fine to write most of the time. R is equal to the square root of x squared plus y squared. Okay. Next, our angle. So if I have the legs of the right triangle, which are the opposite and adjacent sides, then I could connect them to the angle via tangent, and we can say that tangent of theta is equal to y over x, or we could write that as inverse tangent of y over x is equal to theta. Okay, so let's actually do an example here. And let's pretend we want to find the point -2, positive 6. Those are the rectangular coordinates, and we want to write its polar coordinates. Oh, sorry, I should say polar. Polar. Sorry about that. So that point's going to be somewhere up here, coincidentally, according to this, because I have 1, 2, 3, 4, 5. Oh, probably a little high. Let's put that point right there. So in rectangular, that's at 2, 6, -2, 6. What are its polar coordinates? Well, so we are looking for this angle theta, and then of course this r. So r is usually easier to find, so let's find that first. So r is going to equal the square root, well, I'm going to say r squared. It's going to equal to x squared plus y squared. Oopsies. So that will be 2 squared plus 6 squared is equal to 40, I believe. So, by the way, I did say it's 2 squared instead of -2 squared, but since it's being squared, it doesn't really matter because they're going to end up positive anyway. Okay, so if r squared is equal to 40, then r itself is going to equal the square root of 40 or the negative square root of 40, because remember, we have seen cases where r could be negative, and that would just mean it goes backwards. Hang on to that fact. So let's actually find the angle now. So I'm just going to use degrees here. Well, actually, we'll use radians, but we're going to use a calculator anyway. So if I use inverse tangent here, so theta is going to equal inverse tangent of y over x, so that's 6 over -2. So that's going to be -3. And let's actually write this out. So let's actually calculate this. Okay, so I use my handy-dandy calculator, and I have my inverse tangent at -1.249 radians. Okay. Now, here's why I bring this up. Brought up the fact about using r as the positive or negative square root of 40. By the way, if you wanted to simplify this because it might be unpleasant like that, you could say 2 root 10. Okay, so my angle is -1.2 radians, and my radius, or my distance from the origin, or the pole, by the way, the origin is called the pole when we're talking about polar coordinates. Well, let's see where we are. So this angle is going to be negative, so if that's the case, then what we actually did is we found our angle to be this guy right here, and I'll draw it in green, actually down. We actually found this angle right here. So this is -1.249 radians. Okay, what does that mean? Well, that means that r can't be positive, because if r was positive, pointing in that direction, it's going to be, the actual point would be down here. But based on what we know about rectangular coordinates, the point is not down there. It's actually up here. So we're going to actually want to use negative the square root of 40. So this point right here is actually negative 2 root 10 comma, negative 1.249 radians. Okay. Alternatively, you could just change the angle and use a positive r. So alternatively, you could use this angle by taking this guy and adding 180 degrees, because that's how far these guys are, because these angles are just pointing directly the opposite direction. And so you could do, or positive 2 root 10, comma, and I'm running out of space here, positive 2 root 10, comma, 2.149, or sorry, 1.249 plus pi. So plus pi would equal about 1.893 thereabouts radians. Okay, so why is this necessary? And this is where the graph that I pulled up kind of comes from. So this graph right here, this is the graph of f of, I guess f of theta, we'll say, is equal to inverse tangent of theta. Okay, no, sorry, except not theta, because the output is an angle. I'll just call it x, f of x. So again, x is a ratio, and the output of this function is an angle. Okay, and so we talked about this graph before, where its domain is all real numbers, but its range is between positive and negative pi over 2, non-inclusive. And so what happens here is that no matter what x you plug in, it's only going to give you these angles from the unit circle. So the outputs of this function only exists, you know, from negative pi over 2 to positive pi over 2. And so if your point that you're looking at is in quadrants 2 or quadrants 2 or 3, you have to account for that. Okay. Now the way I would do it personally is, if it's in here, you just use a negative r, because it'll give you the right tangent value. It will just be negative, because over here tangent is positive and tangent is positive over here, but tangent is negative in these two quadrants. But it's gonna work out perfectly the same, because like we saw here, it gives you the right angle. It's just completely 180 opposite of where the point is supposed to be. Okay, so you could just use a negative r there, or you could use a positive r. If you insist on using a positive r, then you're gonna have to add 180 to the angle, and you're good. Okay, so hopefully that helps and clears up any confusion that I might have caused. Hopefully it doesn't add confusion, but sometimes that happens, and you know what? Just let me know. Thanks for watching, folks. I'll see you around.